Hi, my name is Max Gosselin. I'm a second-year master's student here at the IFAS Tropical Research and Education Center. Here in the Tropical Fruit Entomology Lab, we work with a variety of insects and mites that cause damage to the local industry here and transmit viruses to a variety of different tropical fruit crops. My work focuses specifically on passion fruit and the diseases that aphids vector in that system.
Passion fruit is a delicious but scarcely available fruit here in the US. It originates from Brazil and has a sweet, acidic flavor that makes it really good in drinks, snacks, and other processed food products, which is where most people here are most likely familiar with it. After all, most of the fruit that gets imported to the US from Brazil is in the form of frozen pulps and juices. Fresh fruits are often just too expensive to transport to the US, which is why we have a local industry of growers here in the States. It can only be grown in tropical climates, however, which makes South Florida unique and important for the availability of fresh passion fruit in the continental US. A huge barrier to the survival of this industry, however, is the presence of viral diseases. One particular illness, passion fruit woodiness disease, causes a devastating amount of crop loss by both reducing the ability of the plant to produce fruit and by making the fruit the plants do produce inedible. Passion fruit woodiness disease makes the fruit hard and lumpy and reduces the amount of pulp which can be extracted, making the fruit really hard to sell. This disease is so aggressive and widespread that most of the growers in South Florida have to replace their plants every single year to keep up production, even though they're supposed to last several years. Growers should keep an eye out for any yellow speckles and wrinkling of the leaves. These can be caused by a number of viral diseases, but can also be a very early warning sign that your grove has been infected with woodiness. Woodiness is thought to be spread primarily by aphids, which are these semi-social plant parasites that attack plants by digging their straw-like mouthparts into the vascular tissues of the host in order to drink their sap. Incidentally, the aphids that spread the disease in passion fruit don't actually even live on the passion fruit. What happens is they do these dispersal flights every year where they'll grow wings and fly around to find a suitable host plant and land on various candidate plants where they'll just do a light tasting of the plant in order to assess compatibility, which is enough for them to transmit the virus. With passion fruit, they leave almost immediately. They don't like it. So they're on the plant for less than a minute usually. In spite of this, they're still able to infect the plant with the woodiness virus and cause one of the single biggest threats to this industry. At the moment, despite knowing that woodiness disease is a problem and that aphids transmit it, we don't actually know all that much about its spread in epidemiology. The goal of my research is to identify which aphids specifically are of the highest importance in this regard by conducting a large, year-long survey of visiting aphids in 3 passion fruit orchards here in South Florida. We are 7 months into the survey now, and we have been collecting our data using a combination of pan traps and sticky traps, both of which we collect every 2 weeks, as well as active foliage sampling, which we conduct every month. We then process the specimens in the lab, either identifying specimens ourselves or preparing them to be sent to the Florida Department of Agriculture and Consumer Services, so they can identify the specimens. Afterwards, we will be conducting transmission assays to assess the ability of some common visiting aphids to actually transmit the diseases to new hosts as a way of confirming their role in the system. The first step in this process will be to create colonies of aphids using pepper, as well as reservoirs of the virus using passion fruit plants. Individual plants from this reservoir will be isolated in mesh cages and exposed to aphids. These aphids will be allowed to feed on the plant so that the aphids can acquire the virus. The aphids will then be transferred from the virulifera's plant to new cages with healthy plants, where the aphids will be allowed to feed once again in order to inoculate these healthy plants with the virus. We will then observe the inoculated plants for emergence of symptoms over 2 weeks and conduct PCR analyses to determine the virus presence. Our hope with this research is that it can be a starting point for investigation of the epidemiology of woodiness disease, as well as a useful tool for helping control the spread of this virus through vector management. One of the most challenging parts of controlling woodiness disease is that because the vectors don't actually live on the plant, the insects can't be controlled through conventional spraying. We need to actually understand the identities and biologies of the vectors in order to find ways of controlling them, and that ultimately is our goal here.